I wanted to give the children an opportunity to see a glimpse into what engineering offered as a career. And the robotics process gives them that, in that they can see a little bit about computer science, computer programming, and a little bit about mechanical engineering, and get some hands-on experience. So the task that they were challenged with was to build a robot that was a watercraft, and they were challenged to build it such that it could turn left and right, and it would be able to basically drive a figure eight within the water around two obstacles. The robot had to stay both positively buoyant on top of the water and stay stable in the water while still and while in motion. So this was a bit of a challenge, especially for students who've never built a robot before, have never programmed anything before. It was quite a challenge. Now, along the way, we learned a bit of science content as well, a bit of physics content. And this was the introduction to chemistry and physics class, so they're young, so they were new to all of this to start with. We learned a lot about buoyancy and the forces at play on the robot, the forces within the water. They had to learn about propeller systems, and the propellers were all attached. Here, I brought one example with me. When I walked out of the building with this morning, the group that built it was very said, "Where are you going with our robot?" But there are motors attached to the propeller. Now, each motor controls its own propeller, and one of the things they had to learn about was gear systems and gear ratios, because at the beginning their thought was faster is better. And I said, you've got to be able to control this thing in this pool. It's got to go in a figure eight around these obstacles. And they quickly learned faster is not better. Faster gives me less control. So that was an issue for them. So they had to learn about gear ratios and building a gear system that would help them to control the speed of the propeller so that they had better control over the robot in the water. This particular robot was actually really awesome. This thing will turn on a dime. It was amazing to watch this group with their robot. But they learned about infrared technology, because this is the actual handheld controller that controls the robot in the water. And there's an infrared link here on the end, and it talks to an infrared sensor in the box. And there's an infrared sensor for each motor, for each propeller. And so they would write a program using block coding, which we learned a little bit about initially when we did the Hour of Code in December. Some of you all may have participated in that. And so they used more block coding to write a program to control it, which is transferred to the handheld controller. And then each of these rotation sensors, each one of these controls one of the propellers. So they can turn it right, the right propeller, or turn the left propeller, and it will go forward, and it will go reverse as well. They learned about, with trying to keep it stable, they had to learn about center of mass, because most of the time, they were novices, and they would put it in the water, and it would, tilt this way or that way. And once those propellers start moving, if you all have any experience with watercraft, when the propeller starts moving, it changes everything. And they learned a lot about that. We had some challenges along the way. My challenges were, when I ordered from Lego, a lot of the major pieces were back ordered. Well, by the time I got them and I was like, all right, we can go, we had snow, lots of snow. And so we were really behind. So that did kind of put a wrench in some things for me. The kids, their challenges were frustration with building a solid robot. They had to learn about bracing, giving it some really sturdy, a sturdy body. So because you put it in the water, and especially section that starts moving, if it wasn't well built, pieces would fall off, and they would become so frustrated. Then they had to learn, they had to deal with, like I talked about a moment ago, the stability and the buoyancy issues with the motion. Propeller placement was huge. It was really, and I would just kind of stand back and say, well, that's obviously not working. What are you going to do to fix it? And they had to work their way through. But it was funny at first because some of them, you can see, they learned how to place propellers. But at the beginning, some of the propellers were facing opposite directions. They would have them perpendicular. And I was going, that's interesting. Now, let's put it in the water and see what happens when you do that. They learned a lot from that. The gear systems, gear ratios, they learned a lot with that, but it was very frustrating. And then just writing the code and having, the frustration of never having done that before. But it was a great learning experience for them as they went along. One of the big life lessons we learned was teamwork. And this is a quote, I had the opportunity to hear a NASA engineer talk last spring, and she said it doesn't take a rocket scientist to be a rocket scientist. And she said, we say this at NASA all the time. She said, what that means to us at NASA is everybody's good at something, but everybody is not good at everything. And we learn to capitalize on our own strengths. And the kids naturally did this within a group. They would say, oh, you're really good at the programming. I'm not good at this. I'm going to hand this over to you. Oh, you're really good at gears. Why don't you, we're going too fast. We need to slow this down. And they would naturally take their group and capitalize on the strengths of each person, which was really good to watch. So finally, obviously, we had some success, and there is a video following this slide. The thing that I learned quickly was, with this being our first foray into robotics, there was a lot of jealousy, and I got this with a lot. And I got questions, why didn't we get to do this in that class? And are we going to get to do this in our class? And that kind of thing. And then also, I've got a lot of students who are saying, can we just have an elective, robotics elective? We'd like to learn more about this. We'd like just to take the class on this. So that's something maybe you stick around.